In Lesson 8.8, you will solve inequalities by multiplying or dividing both sides. Before we begin, I want to show you what happens when you multiply both sides of an inequality by a positive number, and then what happens when you multiply by a negative number. So let's start with the inequality 2 is less than 10. You agree 2 is less than 10, right? Well, now let's multiply both sides by by positive 2. So the left side is going to be 2 times 2, and the right side is going to be 10 times 2. 2 times 2 is 4, and 10 times 2 is 20. 4 is less than 20. No problems there. Now let's take the same inequality of 2 is less than 10, but this time let's multiply by a negative 2. So I'm going to take both sides and multiply by a negative 2. 2 times negative 2 is negative 4, and 10 times negative 2 is negative 20. The problem is negative 4 is not less than negative 20. Negative 4 is actually greater than negative 20. Anytime you multiply or divide an inequality by a negative number, you're going to have to flip the inequality symbol around to make it a true statement. So that is the only thing that's going to be different about today's lesson compared to when we solved the equations. So you're just going to have to remember, if you multiply or divide by a negative, you flip the inequality symbol. And then of course, instead of an equal sign, it has an inequality symbol in the answer. So in our first example, 7y is greater than negative 42. We're going to start out by drawing our train tracks, and then instead of multiplying by 7, we're going to divide by 7. So y, and then on this side, negative 42 divided by 7 is negative 6. And we are not going to flip the symbol because I divided by a positive 7. It doesn't matter what you start with. It doesn't matter that that was negative to start with. What matters is what you divide by. And since we divided by a positive 7, you do not flip the symbol. Now to check your work, you can plug in the negative 6 to make sure that that's the right number. 7 times negative 6 is negative 42. And negative 42 equals negative 42, so that's good. Now choose a number that's greater than negative 6. I don't know, maybe 0 is greater than negative 6. 7 times 0 is 0. And 0 is greater than negative 42. And since 0 is greater than negative 42, I have the right symbol in my answer as well as the right number. So that's how you can check it to make sure it works. Now let's try the next one. I'm going to rewrite this so I have room to show my work. 1/3 x is less than or equal to 8. Remember, when there's a variable attached to a fraction, the quickest way to eliminate that fraction is to multiply by the reciprocal. The reciprocal of 1/3 is 3. So I'm going to multiply both sides by 3. 3 times 1/3 is just 1, and 1 times x is x. And then 8 times 3 is 24. Since I multiplied by a positive, I'm going to leave the symbol the way it was. So x is less than or equal to 24. To check your work, you plug in 24. 1/3 of 24 is 8, so that works out. And now choose a number that's less than or equal to 24, such as 0. 1/3 times 0 is 0, and 0 is less than or equal to 8, so that is the correct answer. Now you may want to pause the video and try the next 3 on your own. To get the p by itself, instead of multiplying by 9, we're going to divide by 9. 81 divided by 9 is 9. We divided by a positive, so keep the symbol the same. And 9 divided by 9 is 1, and 1 times p is p. Now when I write my final answer, though, I'm going to put the variable first and the number second. It's pointing at the 9, and it's opened up or eating the p, so it's going to look like that. And you know how you can check that answer. In the next example, instead of dividing by 4, we're going to multiply by 4. 4 and this 4, those 4's are going to end up canceling out and becoming just n. And since I multiplied by a positive 4, I'm going to keep the symbol the same. And then 16 times 4, 16 times 4 is 64. And since it's negative 16 times 4, it's going to be negative 64. So the solution is all the numbers n that are less than negative 64. And the last one, instead of multiplying by 3, we're going to divide both sides by 3. And since I divided by a positive, the symbol's going to stay the same. 45 divided by 3 is 15. So the solution is all the numbers that are greater than or equal to greater than or equal to 15. Next up, we have a divided by negative 2 is greater than or equal to 8. I'm going to write this below so I have room to show my work. Instead of dividing by negative 2, we're going to multiply both sides by negative 2. And that's going to cancel these to become just a. And on this side, 8 times negative 2 is negative 16. And since I multiplied by a negative, I need to flip that symbol around to being less than or equal to negative 16. Now to check my work, if I plug in negative 16 divided by negative 2, that's 8, so that works out. Now choose a number that's less than or equal to negative 16. How about negative, less than or equal to negative 16? How about negative 20? If I plug in negative 20 divided by negative 2, we want to see if that's greater than or equal to 8. Well, negative 20 divided by negative 2 is positive 10, and 10 is greater than or equal to 8. So it checks out. In our next example, instead of multiplying n by negative 6, we're going to divide by negative 6 to undo that multiplication. Negative 24 divided by negative 6 is going to be a positive 4. Since I divided by a negative number, I'm going to flip the symbol around. And negative 6 divided by negative 6 is 1, and 1 times n is just n. Now if I write this with the variable first, the symbol is pointing at the 4 and it's opened up to the n. So the numbers n that are greater than 4. Now to check this out, I'm going to plug in 4 first of all. Negative 6 times 4 is negative 24, so that works out to be equal. Now choose a number greater than 4, such as 5. And now we're going to see if negative 24 is greater than negative 6 times 5. Well, negative 6 times 5 is negative 30. And negative 24 is greater than negative 30 because remember, negative numbers, it's kind of the opposite of what you would think. Negative 24 is bigger than negative 30 because it's closer to 0. Now you may want to try the next ones on your own. Instead of multiplying by negative 5, we're going to divide by negative 5. So I end up with 1d. And since I divided by a negative, I'm going to flip the symbol around to be less than or equal to negative 6. In the next example, instead of dividing by negative 8, we're going to multiply both sides by negative 8 to undo that division by negative 8. Negative 8 times negative 3 is 24. And since I multiplied by a negative, I'm going to flip the symbol around, and I'll be left with just w on the other side. Now to write this with the variable first, it's pointing at the w and opened to the 24, so w is less than or equal to 24. And the last example of this type, instead of dividing by -7, multiply by -7 on both sides. On the left, you'll end up with just C. We're going to flip the symbol around because we multiplied by a negative. Now a -14 times a -7 is going to be a +98. So C is greater than 98. Now our last example type is a word problem. Manny was trying to break his school's record by getting 61 hits in one season. Halfway through the season, he already had 34 hits. Manny averages 2 hits per game. Write and solve an inequality to find how many more games it will take at that rate for Manny to have at least 61 hits, and then interpret the solution. Well, if he's already had 34 and he gets 2 per game on average, 34 plus 2 times the number of games, and we want it to be at least 61, that means we want it to be greater than or equal to 61. Now to solve this, we would subtract 34 from both sides. And on the left side, you would end up with 2G is greater than or equal to 61 minus 34. 61 minus 34 equals 27. Now you'd have to divide both sides by 2. So G is greater than or equal to 13.5. Now if we assume that he only plays full games, he would have to play at least 14 more games to reach at least 61 hits. So 14 or more games. You may want to pause the video and try the next one on your own. Joan has a total of $250. DVDs cost $18.95 each. Write and solve an inequality to find how many DVDs she can buy and still have at least $50. Well, if she has $250 and she's buying DVDs that are $18.95 each, we're going to take 250 minus $18.95 times the number of DVDs. And let's use D for the number of DVDs. And we want to have at least $50 left. So her money needs to be more than or equal to $50, or greater than or equal to $50. Now we'd want to subtract 250 from both sides. And you're left with a negative 1895D on the left side. Is greater than or equal to a negative 200. Now you'd have to divide both sides by negative 18.95 to undo the multiplying by negative 18.95. So you end up with D, and we're going to flip the symbol because we divided by a negative. So the number of DVDs has to be less than or equal to. Now we're going to take 200 and divide it by 1895. And that's going to be less than or equal to 10.6 about. So the number of DVDs needs to be less than or equal to 10.6. We can't buy a fraction of a DVD. So in order to have at least $50 left, we would want to round this down to 10 because it needs to be less than or equal to 10.6. So we would say she could buy 10 or less DVDs.